So here we've got a much more simplified example, and I want to really highlight this bit of instruction right here. In the last video, we were very much interested in determining are two triangles similar or not. In all of these problems, the triangles will be similar, yes. So we can use that to solve problems instead of having to ask ourselves whether or not they are similar. They all are. It's given. So here we've got two triangles that are similar, and we want to know this length right here, the length of KJ. Now notice that I did not put the line segment bar over KJ. I didn't do that because when you don't put a segment bar above it, you're talking about the numerical distance between those 2 points. So when I say KJ without a bar above it, what I mean is the distance from K to J. I'm in fact going to write that down. Okay, so because we know that these triangles are similar, we know that there is some number that I can multiply 42 by to get 28, and that is going to be the same as the number I multiply 33 by to get x. So there's something I can multiply by, and this is going to end up being the same thing. If I can find that multiplier, I can use the multiplier to find question mark, KJ. All right, so let's find it out. Now, in class, a lot of the time, my early examples were really obvious. In this one, it's not. I don't know what can I multiply 42 by to get 28. It's not immediately obvious. So what I'm going to do is I'm going to do some division. I know that in order to get that multiplier, I take 28, the shape that I'm going to, and divide it by 42, the shape that I'm coming from. Now, big scary fraction, stay with me. Don't reach for your calculator yet. We're going to go ahead and simplify this fraction down. Okay, this is something I've been meaning to review for a while, and I think it's really important in order to help you remain accurate in your answers. So I'm going to actually scooch over here a bit because we're going to focus specifically on this 28 over 42. We're going to do a quick review of reducing fractions, okay? So I want to know what I can divide out of both of those. And since I don't know for sure what the biggest thing that I can divide out of both of them is, I'm going to just go ahead and start listing out factors. So I know all of you have done a factor tree before. We're going to do a little miniature factor tree right here. 42 is, let's say, 2 times 21. That's not the only way you could have done it, but 2 is prime, 21 is 3 times 7. So we've got 2 times 3 times 7 on the bottom. 28 is 7 times 4. 7 is prime, 4 is 2 times 2. Now notice we've got a 2 on the top and a 2 on the bottom. Well, what's 2 divided by 2? It's 1. Okay. We also have a 7 on the top and a 7 on the bottom. What's 7 divided by 7? That's right, it's 1. These cancel out. So what are we left with? We've got a 2 left on the top and we've got a 3 left on the bottom. 28 divided by 42 is the same as 2/3. Now see, if we had just plugged this into a calculator, we would have gotten 0.6666667, And then you would necessarily have had to round that off, which could have made your final answer inaccurate. So in this particular case, it's very important that we use, that's the worst smiley face ever, hold on, that we use fractions instead of being afraid of them. Because now we know that we can take this 33 here, which is 33 over 1. Remember, all numbers are fractions, or all whole numbers are fractions, right? Because everything is divided by 1. And now that we know what our multiplier is, we can apply it. We're going to take 33 over 1 and multiply it by 2/3. Now again, I'm going to go off to the side here, and we're going to work on this. Because I know that, again, fractions are a source of anxiety for some folks. Not a problem. We're going to do the exact same thing that we did up here. We're just going to apply it to everything. Okay? And in fact, there isn't a whole lot of work to be done here. 33 is really only one thing. It's 3 times 11, and both of those are prime. 2's already prime. 3's already prime. 1 can't be broken down any further. So again, what do we have? Well, I see a 3 on the top and a 3 on the bottom. 3 divided by 3 is 1. So those two kind of cancel out. So where am I left? I have 11 on the top here. I have a 2 left on the top here, and there's nothing left on the bottom but 1. So I get 22 over 1, which we could just call 22. So here we have another pair of similar triangles. Remember, in all of these problems, the triangles are automatically considered to be similar. Now, I don't like the way this problem is laid out because the two triangles, though they are pretty obviously the same shape, are not in the same orientation. So it's hard to tell, is this question mark here, is that equivalent to the 117 or is that equivalent to the 130? It's hard to tell when they're not in the same position. So what I'm going to do is I'm going to cheat. I'm going to go ahead and capture this, and I'm going to paste it. And watch what I do here. Now, it might expand or contract a little bit as I'm moving it, but again, they're similar triangles, so it doesn't really matter. I'm going to turn this over so that it's in the same position as the original. Now, obviously, you don't necessarily have this software at your disposal, so you'll have to do it in your imagination. But now we can see that this 60 corresponds to this 117. And this, let's use a different color, this X corresponds to this 130. Once they're in the same orientation, you can just look and see which one is the same side. So in this second example, I'm going to use a slightly different method of solving these. It is a little bit more intimidating at first, but it is much more useful and will help you through a wider variety of more complicated problems. So same as before, in order to get the multiplier from 60 to 117, we can take 117 and divide by 60. And that gets us our multiplier, whatever it is. Now, I'm not going to mess with that just yet. Okay? I also know that I could get the same multiplier by taking 130 and dividing it by x. Right? I take 130, divide it by x, and that will also give me the multiplier between these two triangles. And because the two triangles are similar, these two ratios, these two proportions, these two multipliers must be equal. And this is how you're going to set up most of your problems. You're going to find the ratio for each set of sides, and you're going to put an equals between them, and then you can go from there. Now, the most common way to deal with two proportions being equal to each other is cross multiplication. I'm not a huge fan of cross multiplication, but it's very popular, so I'm going to teach it. You start by multiplying this way. Let's make that a little bit nicer. You start by multiplying this way. Okay? So we get 117x equals. Then we multiply this way. You can see why it's called cross multiplication. Doesn't matter which order you do it in, but you do need to go from the top of one fraction to the bottom of the other. So now it's okay to go ahead and bust out a calculator at this point. When you're dealing with numbers that are this large, there is no shame in grabbing a calculator and just hoping. So 60 times 130 is 7,800. And then last step, divide both sides by 117. We get x equals 7,800 divided by 117. Enter. 66.67. So 66 2/3 is our answer. So this length right here, UT, is 66 2/3 units long. So again, to recap, we know that to get the multiplier from this side to this side, we take 117 and divide it by 60. We know that to get the multiplier from this side UT to this side KL, you would take this value 130 and divide it by x, whatever x is. Because these two are both proportions of similar triangles, they must be equal to each other, so we slap an equal sign between them. And then we learned how to cross multiply in order to solve this proportion. If you have any questions, please feel free to post them in the comments or come on into my office hours, 4 p.m. to 6 p.m. Monday through Friday. Let's move on. We got some more ground to cover. You'll notice, by the way, that I leave the problem up for a few seconds before I move on to the next one. That is to give those of you who need some time to write it down a moment to pause the video and write stuff down. I know that not everybody writes at the same speed. And unlike in a regular class, you can pause and go at your own pace. So example 3, this is one of the kinds of problems that has really been frustrating a lot of students. So let me highlight for you the two triangles we're talking about. Here's one triangle, BUC. Now, our minds are sort of trained to see this trapezoid here as its own shape. But in reality, it's not. It's actually this whole triangle. Okay? So you've got one small triangle and one large triangle, and we know they are similar because the problem says so. Okay? So let's recopy these triangles down, but we're going to separate them and label them separately so that we don't get confused by all these numbers. We want to get back to a problem that looks like this. We want to get back to a problem that's nice and simple where we can find a ratio and make it equal and everything will be fine. When you've got two triangles overlapping each other, it's very easy to mess that up. So we're going to separate these two out. Here is the larger triangle, and here is the smaller triangle. Now you'll notice that I didn't draw the diagram exactly the same as the diagram is on the problem. It doesn't matter so long as you label it properly. Now, this smaller triangle here has a bottom side of 6. In fact, let's move this up. Get these sort of next to each other so it's convenient. Okay, so this smaller triangle, the bottom side is 6, and we don't really know what this side is yet. We'll figure it out in a moment. We also don't know what this side is, and we're not going to figure that one out. Okay. The larger triangle. Now, it can be very tempting to say that the bottom of the larger triangle is 18, but it is not. It is absolutely not. Big frowny face with a tear coming out. It is not 18. This side here is 18 and 6. Okay? It is 18 plus 6. So it's 24. Now, this side here, US, we probably should have labeled these, is 12. Now, we still don't know what this side is, but since we know that this whole side here is 12, and we're going to call SB, let's call it X because we're super creative. Well, you know that this X plus whatever this is have to equal 12. That's what the problem says. So whatever X is, to find this length, you would subtract that X from 12. And I can prove it to you, because if we add these two up, 12 minus X plus X, we get 12. So let me go over that one more time. This whole length here, SU, is 12. We're given that in the problem. This partial length, SB, we don't know what it is, so we give it a name, X. And because we know that the whole thing is 12, this whole SU is 12, then BU must be 12 minus X. So we're going to call it 12 minus X. And now we can set up our proportion. We can say that 6 over 24 and 12 minus X over 12 are equal. Again, it is so much easier to see when the two triangles are separate and labeled separately. There's no way that I would have seen 12 minus X unless I separated out the triangles and really looked at what each side must be. Okay, so now let's focus in on our proportion here. And let's use that nifty trick of cross-multiplying that we just learned. 6 times 12 is, I believe, 72. 24 times 12 minus X, now be careful, there are parentheses here, so don't forget to distribute. 24 times 12, I'm actually going to go ahead and use a calculator for that. 24 times 12 is 288 minus 24x. And now it's algebra. 72 minus 288 equals, so I'm going to subtract 288 from both sides. I get negative 216 equals negative 24x, running out of space, divide by negative 24, divided by negative 24, we get x equals 9. If you didn't follow the algebra that I used to solve for that, I will go ahead and tag a Khan Academy video right now that will lead you to solving multi-step problems with distribution.